Hello everyone, and welcome to the K-means Clustering Project Solutions lecture. In this lecture, we're going to begin going through the solutions for the K-means Clustering Portfolio project. Let's go ahead and get started by jumping back to the notebook. Alright, here I am at the notebook. I'm going to go ahead and get started by answering the questions or completing the tasks. We wanted to import the libraries we usually use for data analysis. Well, we always have pandas as PD, and maybe we need NumPy, so we'll go ahead and say NumPy as NP. And then we also have our data visualization libraries. So we have matplotlib.pyplot as PLT. We'll import Seaborn as SNS. And then since I'm using the Jupyter Notebook, matplotlib inline. All right. Then we want to read in the college data file using readCSV method. So I'm going to go ahead and say df is equal to pd readCSV. And we can just type in college, C-O-L-L, and then we can actually just tab autocomplete to get college underscore data. Note that it does not have the .csv ending. And we also wanted to figure out how to set the first column as the index. You can do that by passing the parameter index underscore col equals, and then you can actually just specify what column index you want to be the actual index. So we want the very first column at index 0 to be the index column. And then with that, we can go ahead and check the head of the data. And it should look like this. So we have our various columns here, and if you want a reference to what these numbers actually represent or what they mean, you can always just read here things such as the accepted number of applications or how many new students were enrolled, etc. All right, we can also use the info and describe methods. So seeing .info, we see how many entries we have, and we have 18 columns. And describe is a nice way to quickly see the statistics behind these column values. So you can see the max, the min, standard deviations, etc. Let's go ahead and move along to creating some exploratory data analysis visualizations. We'll start off by creating a scatter plot of the grad rate versus the room board. And we'll have the hue be colored by the private column. We'll go ahead and say SNS. And to do a scatter plot, you can either do plt.scatter, but since we want to use Seaborn, a trick you can do is use SNS-lmplot, and then say x is room board, and then have grad rate to be y. Our data is going to be df, set hue to private, and if I just run this, you'll begin to see we start to get the sort of scatter plot we want, but I actually don't want these fit lines, and I can remove them by specifying fit underscore reg, or that fit regression, equal to false. And now I begin to see the plot I wanted. We can also do other arguments or parameters, such as saying the palette is equal to cool warm, set size equal to 6, and aspect equal to 1 if you want to kind of change the size of the actual plot, maybe make it a little larger for it's easier to see. But that's the basic idea. It's a little tricky with Seaborn to do these sort of scatter plots, but the idea was do an LM plot for a linear model and then set fit underscore reg for fit the regression line equal to false. And then you'll just have a nice scatter plot colored by whatever column you want the hue value to be. In this case, private. Moving along, now we want to create a scatter plot of f.undergrad versus outstate, where the points are also colored by this private column. That's actually really easy. We can just copy and paste what we have up here already. I'm going to remove palette cool warm, and I'm going to change room.board to this outstate column, and then grad.rate is going to be f.undergrad. We'll go ahead and run this, and we have this plot. And we can already tell just by the out-of-state tuition column versus the number of undergrads private versus public schools tend to be very different from each other. So the tuition tends to be much higher for these private schools versus there's kind of a clear cutoff point for the tuition of a public school. And you can also see these public schools tend to have much higher rates of undergrads versus these private schools, which makes sense. Private schools are usually smaller and more expensive versus public schools, a little cheaper and much larger student body. Now what we want to do is create a stacked histogram showing the out-of-state tuition based on the private column. And I also said try using Seaborn's facet grid to do this. And if that's too tricky, you can also do it just by combining two instances of pandas plot with the kind being equal to histogram. Let me go ahead and show you how you can do this with sns.facetgrid. I'm going to say G is equal to sns.facetgrid. Pass in my data frame, and I want the hue to be again private, so the private column. To match the coloring I have here in the notebook, I'm going to say palette is cool warm. And then what I do here is I say gmap, and then I map matplotlib's histogram, plt.hist, on the outstate column, and then I can keep putting in parameters here, such as the number of bins and what I want my alpha value to be for some see-through. And then we can go ahead and create a very similar histogram. Now this is quite small, so in this facet grid I'm going to add some arguments such as size is equal to 6 and aspect is equal to 2. And then we get a very similar plot here. And you can mess around with the bin values or the alpha values or the palette depending on what you want this plot to really look like. Again, this is quite tricky to do with facet grid. We've already shown previous examples in other projects on how to do this with two stacked versions of a pandas visualization off of the pandas column. So we'll go ahead and just leave it at this for now. And we'll create a similar histogram using the grad rate column. This is, again, just basically grabbing this, copying it, pasting it, and instead of outstate, we're just going to do grad rate and run that. Okay, taking a quick look at these histograms, we can again see that out-of-state tuition for these public schools tends to be much less than the out-of-state tuition for these private schools. And on the second histogram, we can compare the graduation rate frequency count for public schools versus private schools. And both tend to look to be normally distributed, but you'll notice that there's, here in the private school in blue, there looks to be a graduation rate that's actually higher than 100%. So that doesn't make any sense. You can't have more than 100% of students graduate. What we want to do is find out what is the name of that school. So what is that bar actually representing? Well, that's actually quite easy to do with pandas. We can say find df of df grad rate greater than 100. And if you run that, you'll get back this entire row. And this is the Casanova College, which if we go all the way over here to the grad rate, if we can find that column, it's 118%. So that doesn't make sense. So we're going to set that school's graduation rate to 100 so it does make sense. And a quick note, you may get a warning, not an error, when doing this operation. So use data frame operations or just redo the histogram visualization to make sure it actually went through. I'm going to go ahead and show you what I mean by this. I'm going to set df grad rate. Then I'm going to grab the college name. If we go ahead and take a look at it again. Whoops. It was the Casanova College. And I'm going to set that equal to 100. I'm going to go ahead and run this. And note, I do get a warning. The value is trying to be set on a copy of the slice of the data frame. So what you can do, this warning is basically just telling you, hey, you're actually affecting your original data frame. So if I copy this and paste it here and run it again, now note that it no longer exists. And we can check that with another method just by doing this visualization again. So if I copy this visualization and paste it here again, notice now it stops right at 100 where we expect it to. All right, now it's time to actually do the k-means cluster creations. First thing we want to do is import k-means from scikit-learn. We'll say from sklearn cluster import k-means. And then we're going to create an instance of a k-means model with 2 clusters, which makes sense because we know we expect 2 groups, private versus public. So I'll say number of clusters, and let me make sure I'm actually typing this correctly. This should be k-means. And the number of clusters is going to be equal to 2. And I want to fit this model. So I'll say k-means.fit, and I'm going to fit it to all the data except for the private label. And notice we don't do a train test split here because that wouldn't make sense on an unsupervised learning algorithm since we don't actually have labels to split. And then I'm going to say access is equal to 1. So fitted on all the features, and now I want to know what are the cluster center vectors. Remember from the lecture, we can just grab those by saying k-means.cluster_centers_, and this will return back the centers. And notice the number of dimensions on this. This is going to be the exact same number of dimensions as you had features in your data set. Now, as far as the evaluation, like I mentioned before, there is no perfect way to evaluate clustering if you don't already have those labels. However, since this is just an exercise, we do have the luxury of the label, so we're going to take advantage of this just to compare how well k-means clustering on its own with no labels put in can detect the differences between these 2 school types. In order to do this, I'm going to create a new column for the data frame called cluster, which is 1 for a private school and 0 for a public school. There's lots of different ways you can do this, but just to show you a reminder of how to use the apply method off a data frame, I'm going to create a function called converter that takes in cluster, and if cluster is equal to the string yes, I'm going to return 1. Else, return 0. And just to make it clear, let me actually just convert this to private instead of the word cluster. So it's a better choice of words here. All right, then I'm going to say df of cluster, make a new column called cluster, and set it equal to df private dot apply my converter function. And now if I take a look at the head of my data frame, it'll look like this. If we go all the way to the end, we have a cluster which is 1s and 0s, and it lines up perfectly with this column right here, private, yes or no. And all we had to do basically is just convert this private column from yes and no strings to 1s and 0s. Now we're going to create a confusion matrix and classification report to see how well the k-means clustering worked without being given any labels. First thing we want to do here is say from sklearn.metrics import the confusion matrix and the classification report. And then let's go ahead and print those out. We'll say print confusion matrix, pass in the cluster column versus what we thought were the labels using k-means. And we can do that just by saying k-means.labels. And we'll do the exact same thing. Let me go ahead and print a new line here. And then we'll do the exact same thing for the classification report. Let's go ahead and run this and see how we did. Okay, so taking a look at this, we do have quite a few errors, quote unquote. But remember, this is not so bad considering the algorithm is using pure features to cluster the universities into 2 distinct groups. And their precision and recall are actually not so bad. Again, keep in mind, in most settings, you're not going to be able to do a confusion matrix or a classification report on k-means clustering, because that implies that you already have the labels. And if you already had the labels, you wouldn't use an unsupervised learning algorithm. Okay, before we end this, let me go ahead and just review everything we did as we went along through this project. We imported the libraries we needed, we got the data, did some very basic checking of the data, and then we did a little bit of exploratory data analysis. Now, this exploratory data analysis was definitely harder as far as the functionality we had to grab from Seaborn than what you've seen before. So if it was quite a challenge for you, don't worry, it was meant to be that way. And if you had a reference to solutions, definitely don't feel bad because this was pretty challenging visualizations using just the Seaborn library. The scatter plot The trick to this was using Seaborn's LM plot and setting the regression line fit to false, or you could have just gone with matplotlib's own plt.scatter. And then we also created another scatter plot of the undergrad versus out of state. And here we can see there's definitely some separation here between the two classes. Then we created a stacked histogram using Seaborn's facet grid. Again, a very tricky visualization to pull off, but don't feel bad if you weren't able to do it without referencing the solution. And then we also did the same thing for the graduation rate column. And that's where we discovered there was some error within our data, that we had a school with a graduation rate that was higher than 100%. We went ahead and got that school, fixed it so that it was 100%. We got a warning just telling us that, hey, you're actually setting a real value on your data frame. And then we checked this by both calling that again to see that it was no longer there, or just by repeating the actual histogram that we saw earlier and seeing that the x-axis is now capped off at 100. Then we went straight to k-means cluster creation, import the k-means algorithm, set the number of clusters you want, fit it to all your data. Remember, we had to drop the private because it's not going to take in a label because it's an unsupervised learning algorithm. You can check out the cluster center vectors, which are centers in essentially a 17-dimensional space, or however many features there were. And then we did a little bit of evaluation, but remember, it's unsupervised learning algorithm, so these things are very hard to evaluate if you don't already have those labels. Okay, hope you enjoyed the project, and I will see you at the next lecture.